We're doing 1C from section 6.1, problem 1C. So I've written down the function and the interval that we're given in the problem. Here's the derivative of the function that's found using the power rule. And then I've rewritten the derivative in this way here. Since that's a negative exponent here, you can move it down into the denominator and get that. And then this part here, you can, if you got a fraction times x raised to a power, you can just put that power up. You can put that x up in with the numerator if you want to. Okay, so now we're going to set that derivative equal to 0, although one thing we do need to point out here, if I plug in 0 here, I've got a problem, right? Notice that f of 0 is 0. That means that if I plug 0 into the original function, it's defined. I get an output. But when I plug in 0 here, f prime of 0 is undefined because I'll be dividing by 0. So I have to include that as a critical number. So we've got our first critical number here. And remember, that's like the type 2 kind of critical number, thinking back a few sections. Okay, so next we want to set that derivative equal to 0. So we're going to get 10 over 3x to the 1/3 plus 10 over, or 10x to the 2/3 over 3 equals 0. Now, what I can do to solve this, I can move one of these to the other side. Let's to the other side of the equal sign. So let's write it like this: 10 over 3x to the 1/3 is equal to, and if I move that over, it becomes negative. So negative 10x to the 2/3 over 3. Now, this is nice because it's a fraction equal to another fraction, so I can just cross multiply. So if I do that, let's put the negative on the left side. So 10 times 3 is going to give me 30. I'll stick the negative on the left side. And then if I multiply the other side, I'm going to get 30 this times that. Now x to the 1/3 times x to the 2/3, again, you add the exponents in that case, so that's just going to leave us with x. Okay, so if I divide both sides by 30 now, I'm going to get x equals -1. Okay, so now we always want to be checking when we get these critical numbers, are they on the given interval? And it turns out that in this particular case, they both are, right? 0 is right on that interval. -1 is also on that interval. So our last step then is to plug in all of these endpoints and critical numbers back into the original function. Let's start with -2, f of -2, and I'll put that in the calculator. Oh, geez. Hold on, I gotta enter this a little bit differently. Let me enter it as f of 2. In fact, actually, what I'm going to do here is just, I'm just going to leave that as it would be. So I'll get -2 to the 2/3 power plus 2 times -2 to the 5/3 power. Okay, so now let's get a decimal approximation for this thing. I'm going to have to enter this a little bit differently in my calculator here. So I'll get 5 times cube root of 4. And for this one, let's see. So for my decimal approximation here, I'm going to get about 1.6. Okay, and again, that decimal approximation is good for helping us to determine which one is the actual largest and which one is the actual smallest. Okay, so my next number that I need to plug in here is, let's see, what was the next one? -1. Okay, now in this case, we can actually do this no problem. This is going to give us 5 times -1 to the 2/3 plus 2 times -1 to the 5/3. Now, when we're raising a negative number to a power, we just want to be thinking about what that power actually is. If this 2 in the numerator here is actually squaring, so that's going to be like -1 squared and then a cube root. So that's going to end up being +1. So I'm going to have 5. Now this one, they're both odd numbers here. So if I raise a negative number to an odd power, I'm going to get a negative value. So -2 there then. And so that's going to be 3. Okay, and then finally, I've got room here. The last number that we want to plug in is, actually we had two critical numbers, didn't we? Yeah, 0. So let's do 0. Now when I plug in 0, that's pretty easy. If I plug 0 in there, I'm just going to get 0. And then finally, let's put it over here. The last number we want to plug in is just the 1. And so if I plug 1 in here, and again, it's all up here in the original function, that's pretty easy too. If I plug 1, 1 to any power is 1, 1 to any power is 1, so I'm just going to have 2 plus 5, so that's 7. And so just now compare all of these numbers here of the output values that I got, which is the very smallest one. So it seems to be 0, so we're going to get absolute minimum is 0. And 7, I think, is clearly the absolute maximum. Okay, so we found our absolute minimum occurs at one of the critical numbers, 0, and the absolute maximum occurs at the end point. The other two critical numbers did not result in absolute extreme values, or the end point and the other critical number did not result in an absolute extreme value. Okay?